We're going to talk more about probability in this lecture. The last lecture was on the real basic probability, and this gets a little bit more in-depth because we're dealing with probability with fundamental counting principle, permutations and combinations, mainly combinations. I'd really encourage you to read chapter 11 section 5 and look through the book's examples because they approach it slightly different than I do, and what I want you to do is check out my way, check out the book's way, and use whatever helps you the most on my math lab and on my test. I'll even do a couple problems on this lecture both ways so you can kind of decide which way you like best. One thing for sure you should remember is this, what I have in bold down here. The word and, in probability, the word and means multiply. And you'll see how that's going to help you on these types of problems. Okay, here's what you're going to do. You're going to flip a coin once, then you're going to roll a die, and then you're going to spin the spinner. We're going to find the probability of flipping a heads, so we have a heads, and rolling a number greater than 4, and then we have to spin a diamond. So what's the probability of doing those three things and having those three events occur? Well, what you do is remember that the word and means multiply. So what is the probability of flipping a heads when you flip a coin? Well, it's 1/2, 1 out of 2, because there's either going to be heads or tails, and one of them is heads. So the desired outcome is heads. The total outcomes is heads and tails, which is 2, so that's why it's 1 out of 2. The word and means multiply. Okay, what's the probability of rolling a number greater than 4? I bet you agree it's 2 out of 6, because the 5 and the 6 are greater than 4, so it's 2 desired outcomes, 6 total outcomes. So 2 out of 6, which becomes 1/3 when we simplify that, times what's the probability of spinning a diamond? Well, if you take a look over here, what do we have? We have 3 diamonds, and there's 8 total, so 3 out of 8. Remember, the word and means multiply. That's why I put these multiplication signs here. So we get 1 times 1 times 3 on top, 2 times 3 times 8 on the bottom, which is 48. So the probability of those three things occurring is 3 out of 48, or simplify it to 1/16. Now remember, we could have simplified it quicker by doing this. These 3's cancel to give me 1 on top and 16 on the bottom also. So keep in mind, the most important thing from that page is to remember that and means multiply, and we're going to add something to that here. We're going to add to that and means multiply, and in probability the word or means add. Okay, or means add, and means multiply. So now we're going to do a similar problem, but this time you're going to do the same thing, and this time though you're going to find the probability of flipping a heads, then rolling a number greater than 4, so that's and, got to get a number greater than 4, then rolling a number, then spinning a diamond. So we have to have heads and greater than 4 and diamonds. Okay, but then it says or flipping a tails and rolling a 3, and then spinning a heart. So we got to have this happen or this happen. So remember, the word or means add, so what we're going to do is find out each of these probabilities and add them together. So heads, remember this was 1 out of 2, this was 1 out of 3 because it's 2 out of 6, and this was 3 out of 8, and that part of the problem when we figured out was 1 out of 16, right? Now over here tails is 1 out of 2, and rolling a 3 is 1 out of 6 because there's only 1 3 on a die, and then this was spinning a heart. Don't know why it disappears like that. And spinning a heart, there's only 1 heart on that spinner, so that's 1 out of 8. It disappeared on me again. I'm not gonna draw it again if it disappears. Okay, this gives me 1 out of, let's see, 12 times 8 is 96. And remember, the word or means add. So the probability of this happening or this happening is 1/16 plus 1/96. Well, 1/16 is the same as 6 out of 96. I multiplied the numerator and the denominator by 6 to get that. So 6 out of 96 plus 1 out of 96 is 7 out of 96. So you have a 7 out of 96 probability of either the first set of things happening or the second set of things happening. Okay, this looks like a long problem, but it's not that difficult, so keep your concentration up and listen carefully. Powerball, and by the way, in my face-to-face classes, we actually play the lottery and I give the students a chance to win $100. No one's ever won it yet, and I'll show you why. I'm never too worried about giving it away. Powerball is a multi-state lottery played in most U.S. states. It's the first lottery game to randomly draw numbers from 2 drums. The game is set up so that each player chooses 5 numbers from 1 to 59 and then 1 Powerball from 1 to 35. So here's what happens. 5 white balls are drawn from the drum with 59 white balls, and then 1 red Powerball is drawn from the drum with 35 red balls. So you win the jackpot if you match all 5 numbers drawn from the white balls in any order and then matching the red Powerball. So with 1 ticket, what's the probability of winning the jackpot? Well, don't you have to get, in order to win it, don't you need to get the first ball right? And, so that's times the second ball right, and you have to get the third ball right, and you have to get the fourth ball right, and you have to get the fifth ball right. And even if all those things, guess what? And you have to get the Powerball right, don't you? That's what you'd have to do to win the lottery. So I need you to think here. What is the probability of a white ball being pulled out of that drum and that being one of the numbers that you've chosen? Remember, you've chosen 5 numbers, haven't you? So you have to think a little bit here. Well, there's 59 balls in there, so the total number of balls is 59, and you have 5 scratched off on your ticket. So you have 5 desired outcomes. You want that ball to be one of those 5 numbers you've chosen. So you have a 5 out of 59 chance of that first ball being one of the numbers that you had marked. Okay? Now, there's no longer 59 balls left in that drum. There's 58 balls left in that drum, and there's only 4 numbers left that you've scratched off. Okay? Now, you lucked out. You got the first one right, the second one right. Guess what? You still only have a 3 out of 57 chance of getting the next one right, a 2 out of 56 of getting the next one right, and a 1 out of 55 of getting the next one right. I bet that makes sense to you. Okay? Now, even if all those white balls turned out right, remember, you've scratched off 1 number out of 35 from the red balls, which is the Powerball. So you still, even if you had all those things right, you don't have a 1 out of 35 chance of getting the Powerball. Now, it'd take way too long to type that into a calculator and take up time in class, so I did it ahead of time. And when you put that into the calculator and multiply it all out, look what you get there. 5.7 approximately, and then it says e to the negative 9. Now what that means, in case you forgot, that's scientific notation on the calculator. So it's 5.7, and when it says e to the negative 9 on the calculator, that means times 10 to the negative 9th. So it approximately equals this. And what that means is move your decimal 9 places to the left. So we're going to take this decimal, and when you move it 9 places to the left, we have to add 8 zeros in front of that 5. So that's the probability of winning the lottery. And as a percent, if I change this decimal to a percent, I have to move the decimal twice to the right. So here we go. You have about a 0.0000057% chance of winning the lottery. That's why I never worry too much about giving my $100 away. Now, that's one way to do it. Another way to do it is use combinations. So, do you agree with this? To pick that there are, if you think about it, we're choosing 5 balls out of 59 balls, right? So that's a combination problem because it doesn't matter what order those come up in. And 59C5 gives us a little over 5 million. Then we have to take that number and multiply it by 35. So you find that right here. That 5 million number, the 59C5, is right here. Then we have to take it times 35 because there's 35 combinations of numbers when you pull out of the red drum, and that gives you this huge number right here, 175 million. So you have a 1 out of 175 million chance of winning the lottery, and guess what happens when you divide 1 by that 175 million? You get approximately this right here, which is what I had on my calculator, which is what we just discussed a second ago. That's your probability of winning the lottery. So you can do it by using the word and the fundamental counting principle, or you can do it by using combinations, the 59C5 times 35. Okay, now this is just like the lottery problem, so I'll come back to it if we have time. I want to make sure I get to a couple other things first, and then if we have time I'll come back. Write a probability statement here. An experiment consists of dealing 5 cards from a standard 52 card deck. What's the probability of being dealt 5 black cards? Well, do you agree with this? That it doesn't matter what order those cards come out, but there's 52 cards in a deck, and since the order doesn't matter, we're going to use C and 5. So that denominator is the total number of 5 card hands you can get when you're dealt 5 cards. But we want to know the probability of being dealt 5 black cards, so this becomes 26 C5 up here, because there's only 26 black cards in a deck, so the desired outcomes are only the 5 card hands that are black, and the number of those is given by 26 C5. Okay, and you know what? Do I have time to do this? Let's try really quick. So let's go 26 math probability C5. Okay, that gives me 65,780, 65,780, and then I have to do 52 C5. Okay, let's do the combination of taking 5 cards out of 52, and we get 5. And you know what I'm going to do? Well, all we're going to do now is we want to divide that 65,780, because that's in the numerator, by that answer, don't we? So we're going to divide it by that answer. You can hit second negative sign, and that's the answer. And there is our probability, about 0.025. About 0.025, which is the same as there's about a 2.5% chance that you'll get all black cards when you're dealt a 5 card hand. Alright, let's say they decided to invent a new game. It involves putting 40 ping pong balls numbered 1 to 40 into a big paper bag. Here's how you win the game. Pick out 3 ping pong balls at random. If you pull out an even number on the first ball, so we have to get even for the first ball, and then we have to get the number ending in 5 on the second, so that'd be ending in 5, and then a ball, the number 23 is your third one. That's how you can win. Or if the first ball you pull out is ball number 1, you also win. So here we go. Chances of getting an even number are 20 out of 40, which is the same as 1/2, and means multiply. Ending in 5 would be the numbers 5, 15, 25, and 35. So there's 4 of those, but guess what? There aren't 40 ping pong balls left in the bag. There's only 39 in there because we already pulled one out here, right? And then number 23, there's only one way to pull out a 23, and there's only 38 ping pong balls left in the bag. So what we're going to do is multiply all this together, and then we're going to add it to, because of the OR. And how many ways can you pull out a number 1 on the first try? There's only 1 out of 40 ways to do that. Remember, that's either this is going to happen over here or this is going to happen here. That's why we're going to add it. And this number is a 40 because it's like starting the experiment over again. Well, I already did the math ahead of time because I knew we were going to run short on time. That gives us about 0.0421. So there's a 4.2% chance of winning that game. All right, thanks for coming or watching. Bye.